Hello, my dear students. Welcome back to the lecture. So in this lecture, we'll try to see the other part of the interview questions, right? So far we understood about the concrete, and also we understood what are different types of curing. This is also a very important question. They may ask you what is admixture, right? So we'll try to see that what exactly are admixtures. Okay, so you can see it here, right? See, whenever we prepare concrete, we use cement, coarse aggregate, fine aggregate, and water. This is a normal practice what we do. Admixtures are those things which we add in the concrete to modify the properties of a concrete. If somebody asks you what is admixture, one line definition will be to change the properties of the concrete or to modify the properties of the concrete, we make use of admixtures. Got it? Very simple answer. Yeah. These are additional substances, ingredients which are added in the concrete to modify the properties of a concrete as per the requirement. Now you can add one more point. You can say that admixtures are the fifth ingredient which is present in the concrete. It is not a essential ingredient, but it is a fifth ingredient. I'll tell you what do you mean by essential ingredient. Nowadays, admixtures are very important for concrete. We can say that it is one of the most important ingredient of the concrete, which is called as a fifth ingredient, but it's not an essential ingredient. That is, cement, sand, water, and coarse aggregate are four ingredients. If you add admixture, it is a fifth ingredient, but it is not an essential ingredient, but it is an important. Essential in the sense, without the help of admixture also we can prepare the concrete and we are okay with that. But when it comes to modifying the properties of a concrete, then we have to make use of admixture. Very good, right? Again, other than that, this is not required. For your understanding, I've added. Very one line question, one line answer is that admixtures are those things which are added to the concrete to change the or to modify the properties of the concrete. Nowadays, you can add one more point. We nowadays admixtures are become popular, and it is, you can call admixture as the fifth ingredient of a concrete. This much is enough. Yeah. Now, if you have seen it here, admixtures are classified in many ways. Okay, we have two types of admixtures. If they ask you, can you elaborate that? Then you can tell that in admixtures we have two types. One is we have a chemical admixture. The second one we have a mineral admixture. First, we'll try to see what are chemical admixtures. So in chemical admixtures, we have accelerators, we have retarders, we have water reducers, we have super plasticizers, we have air entering admixtures. When it comes to the mineral admixtures, we have fly ash, we have GGBS, we have silica fume, we have metakaolin, and then we have rice husk ash. So if you remember this well and good, all the explanations are not required, right? So coming to the accelerators, in accelerator, what will happen? It will increase the setting of your cement, right? That means, let us say you're doing, I'm giving you one word explanation, you can note it down and not put the explanation here, right? So let us say you're doing a concreting in a very cold environment. So in that case, what will happen? Your concrete is not going to set, since the environment itself is very cold. It will take long time. So what you're supposed to do, we'll try to make use of accelerator, so that whatever reaction is supposed to happen quickly, it is going to happen. So that is the importance of adding an accelerator. You can give an example. In case of cold climate regions and all, especially if you go to the foreign countries and all, okay, where we don't have enough sunlight and all, what will happen? Your concrete will not get set. In that case, we can make use of accelerator, and the fast setting of the concrete can happen with the help of accelerator. Simple. Come to the next point. What is retarder? So retarder is the opposite of accelerator. In accelerator, what used to happen? Quick setting used to happen. But whereas in retarder, we are going to delay the setting. And I had give a very good example for this in the concrete technology course. If I give you ice cream and if I ask you to eat it after 15 minutes, what is supposed to happen? The ice cream, what I've given you, it's going to melt, isn't it? Then if I want to stop that melting, what I'm supposed to do? I'm supposed to refrigerate. That means if I keep the same ice cream in a refrigeration, or if I refrigerate it for 15 minutes, it's not going to melt. So what I'm trying to do, I'm delaying the melting of that ice cream, isn't it? In the same way, whenever you want to delay that, for example, where is this particular situation coming into play? Okay, let us say you want to transport the concrete from one place to another place. Okay, let us say right now I'm here. This is a place where my concrete is being manufactured, and let us say this is a place where I want my concrete to be placed. This is a site where I'm working, and let us say the distance between these two sites from here to here, let us say it will take for me to reach here, it will take me 2 hours. Okay, or let us say 1 hour. 1 hour it will take for me to reach my concrete, okay, from my batching plant. This is my batching plant to the site, and we know that within 30 minutes, of course, yes, cement is going to, your concrete is going to set. Now if I do the transportation for 1 hour, obviously by the time it will reach to my site, my concrete will get set. If my concrete has got set even before placing, then what's the point in bringing the concrete? So if I want to delay that setting, I will make use of the retarders. So what this retarder will do, after adding the retarder, my concrete reaction or my concrete is not going to set immediately. There will be a delay in the reaction of that. So that is why we make use of retarders. Application, again for a very same application, where we do the transportation of this concrete and all from one place to another place, we can make use of retarder. In the same way, if you're doing a concreting in a very hot climate, let us say if you go to Middle East and all, the temperature most of the time will be 50-55 degrees Celsius. So in that case, what will happen? The moment you pour the concrete, it will get set due to a lot of evaporation and all, and also due to more heat. What will happen? Your concrete is going to set quickly. So the laborers are not able to place the concrete easily. So in that case, we will make use of retarders, so that what will happen? Your setting will not happen. If a setting doesn't happen, your laborers are having enough time to place the concrete. So these are the two explanation what you can give for the accelerators and the retarders. Water reduces, superplasticizes, and this I'll explain you in the next slide. Just try to understand. Coming to the mineral admixture, we have fly ash, GGBS, silica fume, metakaolin, and rice hash. So see, I'm not writing anything here. Just listen to me. During the manufacturing of a cement, we have seen that a lot of carbon dioxide is being released, and carbon dioxide is not good. And as a result of that, what has happened? There are a lot of steps are being taken by the government and all that we don't want to release the carbon dioxide. So if I want to reduce that, what I should do? I should reduce the consumption of the cement. I can reduce the consumption of the cement only if there is a no need of cement. But our construction industry is moving in such a phase that we require so much of cement. So we cannot stop that. So what we do, we make use of certain admixtures like fly ash and GGBS. For let us say, instead of putting 100% of the cement, I'll put only 70% of the cement, and remaining 30% I'll make use of fly ash and GGBS. So that what will happen? I have reduced the consumption of the cement. So I'm making my cement more eco-friendly. And also this fly ash and GGBS have got their own problem. This fly ash is a waste product which comes from the steel industry, and GGBS is a fly ash. GGBS is a waste which comes out from the manufacturing of the steel, and fly ash comes from the coal industry. Yeah, sorry for that. Fly ash comes from the coal industry. It's a byproduct what you get during the manufacturing of a coal, and GGBS is a byproduct what you get during the manufacturing of the steel. They're very fine in nature, and it's very difficult for that industry to dump it. Even though you dump it somewhere, you require a huge amount of land. Again, you're investing into the land, and even you cannot simply spread it there. Again, you require a big silos for that to store all those things, right? So again, if it comes in contact with air, again what will happen? There's a lot of problem for human beings. If I want to stop all these things, the best reason what I can do is I can try to mix with the cement, and while doing mixing of a cement, it has got its binding property. Only fly ash has no binding property, but fly ash when mixed with the cement and all, it will give more binding property. If you remember, I'll tell you one thing. We had seen that tricalcium silicate, when I added with the water, right? What used to happen? This CSH gel used to form, right? So the CSH gel used to give the binding property to the cement. Again, if you try to add fly ash and GGBS, no, the more and more amount of CSH gel is going to form, right? So that is the main advantage of using a fly ash and GGBS. But this much explanation if you give, it's enough. You don't have to explain so much like fly ash is so and so. And under the fly ash, we have classification. We have class C fly ash and class F fly ash. That is all not required for your level. Interview level, you can, whatever explanation I have done, no, try to understand it in a more better way and try to put in your own language, and that's a better explanation you can do. Silica fume, metakaolin, and rice hash are not needed. Very less time we try to use it, and these things you can do a research on this. You can take as your academic project and try to work on this. But interview level, try to understand about fly ash and GGBS. We have a fly ash bricks also nowadays. We have a cement block. In the same way, we get fly ash bricks. So that is how the fly ash is being utilized in different industries, and that is how we are trying to make our cement and all in a more eco-friendly way. Got it? This much explanation is enough. Then they may ask you about the retarder. Can you told about the retarder, right? Can you name some of the retarder? We can tell sugar. Sugar is a very good retarder, right? If you add a certain amount of sugar in the concrete, it's going to delay your setting. You can say gypsum. Of course, if you remember, during the manufacturing of a cement, we used to add gypsum, right? Why that gypsum was added? So that you are going to delay that setting. So again, that was acting like a retarder. So you can say gypsum is a good example for retarder. You can say tartaric acid is a good example for a retarder. Sugar is a good example. Of course, starch is a product of that, right? So you can remember these 4 as an example, and you can say that these are the retarders what we can do. Coming to the accelerator, you can say 𝗕𝗂 is a very good brand. Just remember the brand of this. 𝗕𝗂 is a very good brand where they are going to manufacture all kind of accelerator. You can see it here, rapid hardening admixtures are used. Okay, so in this way, if you try to remember, you can give a better answers to all these questions. Don't have to understand so much of big 3-4 lines answer and all that is explained in my course, but here basic understanding, you should understand what exactly you're trying to say. Right, so the interview will come to know you have an idea on this. Got it? Yeah. So I hope you have enjoyed the lecture up to here. We understood what is fly ash, we understood what is GGBS and all those things, and the remaining part we'll try to see in the next lecture. So we'll see you back in the next lecture. Thank you.